Hello everyone, welcome to Physics Mastery Academy. We are going to answer this question. A uniform rod of length L and mass m makes constant angle alpha with an axis of rotation delta. Here is the rotational axis, which passes through one end of the rod. Here. What is the moment of inertia about this axis? So, to answer this, we take an infinitesimal element along this rod and we call it as dx. The distance of this element to this end of the rod is x, and the distance of dx to rotational axis is r, and r is perpendicular to this axis. And the relation between r and x is given by this equation. So this rod is a continuous rigid body. That's why to find moment of inertia, we need to use an integral definition of moment of inertia, which is given by this equation. So, what is dm? dm is the mass of this element, and it can be found by linear mass density times dx, and lambda here as a linear mass density can be found by the ratio of m to L. So if we substitute lambda in dm, we get this equation, and we need r and dm to find moment of inertia. So let's do it. If we substitute these quantities in the integral, we get this equation. And also, since m, L, and sine alpha are constant, they don't change in this question, we can take them out of this integral. And the integral is along this rod. That means x changes from 0 to L. So if we calculate this integral, we get this equation, and by substituting L and 0 instead of x, we can find this final answer, which means that moment of inertia is 1 over 3 m L square sine square alpha. Thanks for watching.